Thank you for your interest in this SemEval 2022 Task 2, Multilingual Idiomaticity Detection and Sentence Embedding. In this screencast, I will talk to you about Subtask B and the data and data format associated with this subtask. This subtask, Subtask B, is a novel challenge that requires the creation of sentence embeddings that represent sentences regardless of whether or not they contain idioms. And we measure this by the use of semantic text similarity. This subtask is constructed using the following principles. Consider this example here, which contains the multi-word expression big picture. Now, big picture has an idiomatic meaning, which is the whole situation, and a literal interpretation, which is large image. Notice how both of these paraphrases of both the literal and the idiomatic meaning of big picture are non-idiomatic. The fundamental principle that we make use of here is that the semantic similarity between this one, the sentence, the original sentence with the multi-word expression, and one where this multi-word expression has been replaced by a paraphrase, which is the correct meaning of that multi-word expression, must be one, as in case 2 here. And that the semantic similarity between this original sentence and the one where this multi-word expression is replaced by the incorrect paraphrase should be equal to the semantic text similarity between this sentence, where it is the correct one, and this one, which is the incorrect one. This is based on the principle that if models can correctly interpret the meaning of big picture in context, then the semantic similarity that they assign to this sentence will be the same as this sentence, and any other sentence will be the same as that between this correct replacement and any other sentence. And thus, what we're actually measuring is the self-consistency of a model, right? How consistent it is in assigning sentence embeddings, and we are measuring this using a semantic text similarity metric. Now, how does this convert to a task? Consider this sample of the evaluation data. Notice how the potentially idiomatic expression, swan song, is replaced by its potential meanings, or the paraphrases of its potential meanings, here and here. Notice also that this is the incorrect meaning in this context, and this is the correct meaning in this context. And therefore, based on the principles that we spoke of above, your model should output a semantic similarity between these two sentences, which is approximately equal to that between these two sentences. Notice that the evaluation program, with the use of the gold labels, will automatically do this. So you don't have to do anything specific or anything different. All you need to do is output semantic similarities between these sentences, and the evaluation program will automatically extract out pairs in the evaluation data that it needs to compare. Now let's look at the last example here. In this case, this potentially idiomatic expression, home run, has been replaced by the correct meaning, or the paraphrase of the correct meaning. And therefore, your model must output a semantic text similarity between these two sentences of approximately equal to 1. The evaluation of your model is based on these two different sets of STS outputs. One, which is between sentences like this, or 1, and the other between these pairs which contain multi-word expressions or potentially idiomatic expressions. And so your model score is the Spearman rank correlation between these two sets of results. Notice also that this subtask is available in two settings. The first is the pre-train only setting, and the second is the fine-tune setting. Now, in the pre-train setting, we require that models are not trained with the training data that we provide, which includes information about multi-word expressions. However, models such as BERT do not output sentence embeddings that can be directly compared using directly compared for semantic text similarity. You must fine-tune it using some STS dataset. So you are allowed to fine-tune these models using standard STS datasets for the pre-trained setting. However, you must not use the training data that we provide, which includes information about multi-word expressions in this setting. Now, there are some restrictions on the STS data that you can and cannot use. Please see the section below where we describe it in this section, data and model restrictions out here. Right. Going back here, we also understand that non-contextual models such as GLAU and Word2Vec do not directly map to this pre-train and fine-tune settings that we've set up. In a sense, what we require is that models that participate in the pre-train setting do not use our STS training data, our idiomatic semantic text similarity training data, which is described here. And models that participate in the fine-tuned version can use this data. Now, the training data, again, is built on the same principles that we spoke about earlier. Notice here that the same multi-word expression swan song has here the incorrect paraphrase, and therefore what this means is that the semantic similarity between these two sentences should be equal to the semantic similarity between these two sentences, right? And similarly, the semantic similarity between these two sentences here must be the same as that between these two. Now remember that this represents case 1, which was depicted here. Notice that this training data does not have similarities provided. And since it requires your model to be consistent, what you first need to do is to create a model that is capable of outputting semantic text similarity. Use that to find the similarity between these sentence pairs, and then train your model so it outputs similar text similarities for these sentence pairs. Now, the pre-processing scripts and an example for this is provided in the Google Colab notebooks, along with functions for all the pre-processing for this. So please go ahead and make use of that. Notice that you also have a case 2 where you have the multi-word expression replaced by a paraphrase that represents the correct meaning. In that case, of course, the semantic text similarity output by a model must be 1, and this is provided within the training data. So your training data will either look like this, in which case you must first output the semantic text similarity between these alternatives and use that as the similarity here, or it will be presented like this, where the similarities are already available and you need not do this. So you need to filter the training data to extract these and handle them separately, and then to extract these and to handle them independently. Notice that in addition to some of this, in the evaluation data, we actually also add some data from standard STS datasets. That's to make sure that your model is not overfitting on the idiomatic data that we provide, and that it can also continue to perform well on standard STS datasets. And for this reason, you must not make use of the development or test splits of these two STS datasets. So remember that regardless of the setting that you're participating in, either the pre-trained or the fine-tuned version, you cannot use either the development or the test splits of these two models, of these two data sets to train your model, right? And in both the pre-trained and the fine-tuned settings, you can make use of the training split of these two settings. In addition, you are not allowed to independently use different methods for the STS subset and the non-STS subset of the evaluation set. So, what do I mean by that? Essentially, you will notice that the evaluation data has, in addition to these rows, which contain information about multi-word expressions and paraphrases of the meanings of these multi-word expressions, there will be some rows associated with standard STS data. You cannot have models perform independently on these two subsets. So you can't filter through the evaluation data and extract out those bits that are specific to the idioms and perform one or use one method or model on that and a different method or model on the STS subset. You must use the same model or method on both of these subsets. You can, however, create use different methods for different languages, and obviously for the pre-trained and the fine-tuned settings, you can use different models for it. But this is important that you use the same model for the entire STS and non-STS sections of the evaluation data. Again, the data for all of this is available on GitHub. To participate in this subtask or the other subtask, please join Colab. The submission format details are presented here, and the baseline script provides details, including the pre-processing scripts for structuring your training data and making use of the format, the submission format, to actually submit a version of your results. Now, what we suggest is that you start by going through this and stepping through the Google Colab notebook, getting the output from that, which will be the baseline output, and using that submission to submit to Codalab, so you understand the process and understand what is required in this subtask. If you have any questions at all, please do not hesitate to post your question to the task mailing list or send us an email send the organizers an email, and best of luck.